This last section in Chapter 9 is on factoring binomials. There's two types of binomials we're going to factor. One is called the difference of squares. And the other one is called a sum or difference of cubes. So those are the two types of binomials. You're going to see some squares and cubes. We're going to start with difference of squares. It's much easier. But before I get into the technique, I want you to FOIL or multiply together these following pairs of binomials. And you can pause the video and do this on your own, or you can just follow along with me. If you do x times x, you'll get x squared. X times negative 4, you'll get negative 4x. Positive 4 times x, you'll get positive 4x. And positive 4 times negative 4, you'll get negative 16. From there, if we simplify, the minus 4x and the plus 4x will zero out, and you'll be left with x squared minus 16. Let's look at the next one. If I have 2x times 2x, that's 4x squared. 2x times positive 3 is positive 6x. Negative 3 times 2x is negative 6x. And negative 3 times positive 3 is negative 9. And again, the two middle terms zero out. And I'm left with 4x squared minus 9. Let's do that one more time. 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. Positive 5 times 3x is positive 15x. And positive 5 times negative 5 is negative 25. And one last time, you see those middle terms zero out, and you're left with 9x squared minus 25. The binomials that you get as final answers, these, x squared minus 16, 4x squared minus 9, and 9x squared minus 25, those are special binomials called the difference of squares. Difference because every single time we're subtracting, and squares because these are all perfect squares. 16, 4, 9, 25, 1, those are all perfect squares. So let's look back at our binomials. You basically have the same binomial twice, but one is plus and one is minus. What that does is zero out the middle two terms. It also always makes that last term negative. So if you have a minus and a plus, it zeroes out the middle, and it makes that last term negative. Last time, positive, negative, zeroes out the middle, makes the last term negative. What we're going to be doing now is going back from here to there. So x squared comes from x times x, and then 16 comes from 4 times 4. So it's like taking the square root of each one. Same thing here. 2x comes from 4x squared, 2x and 2x. 3 and 3 comes from 9. So it's like square rooting both ones. Same thing here. The 3x's come from the 9x squared. If I square root that, the 5's come from 25. So there's really not a procedure for this. We just have to remember the pattern. So let's factor the following binomials. If I have x squared minus 49, the first thing to notice is that it's subtraction and that they're both perfect squares. So I'm going to set up my empty binomials. The square root of x squared is x and x. The square root of 49 is 7 and 7. One's going to get plus and one's going to get minus. And it doesn't matter which one gets which. I'm going to hold off on that one for a minute. Let's try the next one. X squared minus 81. First thing to notice is that it's subtraction. 81's a perfect square, and so is x squared. So I'm going to set up my binomials. I'm going to square root, get x and x. Square root, get 9 and 9. One is plus, one is minus. Notice over here that these are the same binomials, but they're adding. If they're the sum of squares instead of the difference of squares, they do not factor. A lot of students think if we just put plus signs here or minus signs here, it will factor, but then you'll have a middle term. So if you ever have a sum of squares, they do not factor. You can try, but it will not work. So just be mindful of that. Let's look at the next couple. We have difference, and we have perfect squares. So I'm going to set up my binomials. Square root 8 and 8. Square root x and x plus minus, and keep it in the same order as the original binomial. Same thing here, we have subtraction, we have perfect squares. So I'm going to set up my back-to-back binomials. Square root of 25 is 5, and the square root of z squared is z, so 5z and 5z. And the square root of 16 is 4, so 4 and 4. One gets a plus, one gets a minus, and it doesn't matter which one gets which. On the next one, we have subtraction. We have x squared, but 3 is not a perfect square, and 75 is not a perfect square. So if you feel stuck, always look for a GCF. No matter what you're trying to factor, look for that GCF. So if I take out a 3, that leaves me with x squared minus 25, and then you should be able to recognize 25 as a perfect square. So I'm going to have my 3, and then my binomials, that's going to be x and x, 5 and 5. One gets a plus, one gets a minus. And the only difference there is that you have your GCF out front. Same thing on the next one. We notice that it's difference, but 18 is not a perfect square, nor is 98. So if we look for a GCF like 2, that'll give us 9x squared minus 49, and all of a sudden we have perfect squares. So we'll leave the 2, we'll set up our binomials. 9x squared breaks into 3x and 3x. 49 breaks into 7 and 7. One gets a plus, one gets a minus. Again, does not matter which one gets which. So if you're stuck, look for a GCF. Even if it looks impossible, still keep an eye out for a GCF. Let's look at these bottom two here. Let me get the camera fixed so you can see them. There we go. So 16 is a perfect square, 9 is a perfect square, but we have x to the third and this random x hanging out here. So again, we'll look for a GCF, take that x out. That's 16x squared minus 9. Now we have perfect squares. I did not give myself enough space. Alright, perfect squares there. So we have 4x and 4x, 3 and 3. One gets a plus, one gets a minus. So these are really easy if you can recognize them. The hard part is recognizing what you have. So here 8 and 50 are not perfect squares, but I can take out a 2. Y cubed and y are not perfect squares, but I can take out a y. That leaves me with 4y squared minus 25, which all of a sudden becomes perfect squares. So we have 2y, and then our binomials. That's going to split into 2y and 2y, 5 and 5. One gets a plus, one gets a minus. So again, difference of squares is easy as long as you recognize it as squares. And you want to be able to recognize your perfect squares 1 through 100. So 1, 4, 9, 16, 25, 36, 49. You can always make a list if you need to. So 1 squared, 2 squared, 3, 4, 5, 6, 7, 8, 9, and 10. Sometimes the homework gets a little bit higher. 11 squared is 121, and 12 squared is 144. But you've got your calculator to help you out if you don't know all those perfect squares. Alright, so let's move on to cubes. Cubes is a little bit more involved. And once again, these binomials do not have a process to follow. It's just a pattern to memorize. similar to sum and difference of squares. So cubes are to the third power. And so anytime you have two things being added together to the third power or subtracted to the third power, they always break into a binomial and a trinomial that follow this same pattern. A binomial and a trinomial that follow these patterns. I've had trouble with students trying to memorize these patterns. They're very similar. Notice the A's and the B's are exactly the same. The only thing that's different is the signs. So I've had some students really struggle with trying to memorize these, and I've come up with a couple techniques to help you remember, to help your brain kind of follow the pattern. So I'll share those techniques with you. So the two steps to the technique. The first step I call zigzag. That's not an official term, that's just what I call it. And the second step is called same, opposite, add. Again, I kind of modified these from a couple other instructors to, again, help you follow that pattern. So I also recommend making a list of perfect cubes on your scratch paper. One note about that, though, during your exam is when you write it on your scratch paper. You cannot bring pre-written list into the testing center. They will not allow it. So you're going to be given scratch paper for your test, and so on your scratch paper, when it's blank and you're in the testing room, start with a blank. Make yourself a list of perfect cubes, and you can let your calculator help you. 1 to the third power, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You just want to make this list, not necessarily from memory, you can use your calculator, but you cannot bring this list with you to the testing center. You have to make a fresh one. So to do the third power on your calculator, there's a couple different ways. You type in 1, and then there's a button called a caret below the clear key, the up arrow. It's not really an arrow, it's just a caret. And then 3 for the third power. 2 up 3, so 2 to the third power, 3 up 3, 3 to the third power. There's also a math button. If you go to math, option 3 is to the third power, and you can do that as well. It does the same thing. So you can do 4 up 3, that's the faster way, or 4 math, option 3, does the same thing. So 1 to the third power is 1, 2 to the third power is 8, 3 to the third power is 27. Again, you don't have to memorize these. You can let the calculator help you. 5 to the third power is 125. 6 to the third power is 216. Let's see, 7 to the third power is 343. 8 to the third power, 9. And 10. So you just make a quick list of your perfect cubes. Perfect squares you recognize just from previous math courses. Perfect cubes I know is a little bit tougher. But you want to have this nice list with you. I'm going to fold mine up so I can see it better. You want to have that list made on your scratch paper when you go into your exam. So I'm going to show you a couple ways how to do this, and then you can try some on your own. And we'll just keep practicing as needed. Alright. So we have x to the third power plus 8. The first thing to recognize is that you're talking about to the third power, so we're talking about cubes, and that 8 is a perfect cube. So 8 comes from 2 to the third power. So x to the third comes from x times x times x, and 8 comes from 2 times 2 times 2. So you're going to break down your cubes into the roots. So x times x times x gives you x cubed. 2 times 2 times 2 gives you 8. And those are your roots. Then you're going to create a zigzag, and it kind of looks like a letter E with sharp corners. So we're going to make a zigzag. Your zigzag is going to contain A and B, the first root and the second root, and then A squared, AB and B squared. And that just takes some practice getting used to. So A is the root from your first term, which for this example is x. B is the root from the second term, which in this example is 2. Then if you follow the zigzag up, you're going to take whatever your A is and square it. So this time it would be x squared. Then you follow your zigzags together and you multiply A times B, which would be 2x. X times 2 is 2x. Then you follow your B down and square it. 2 squared is 4. So you're going to take your pieces, x and 2, x squared, 2x and 4, and you're going to set up a binomial and a trinomial. You're going to put your 2 terms from the left in the binomial. You're going to leave a weird space in between them, no plus, no minus yet. And then the 3 terms from the other side, x squared, 2x and 4, again with weird spaces in between. We'll fill those in here in just a second. So your zigzag gives you your terms. If you go back up to this pattern here, it gives you your A, your B, your A squared, AB, and B squared. The plus minuses are what get a little confusing. So, and this is actually, that should be a plus. Okay. So to do your plus minuses, you're going to follow same, opposite, add. Same, opposite, add. So the same is whatever you have in the original problem. If the original problem is plus, you're going to put plus. Then you're going to do the opposite of that, which would be minus, and then you always add at the end. So it's same, opposite, add. And then you're done. So it's kind of a different process, but that's what it takes for these sum and difference of cubes. And then you're done. Let's look at it again, because I know that's a weird process. So x to the third breaks down into x, x, and x. 27 breaks into 3, 3, and 3. We'll set up our zigzag. Section that off a little bit. So we're going to have x and 3, your 2 roots. And then we're going to square the x. We're going to bring the x and the 3 together to make 3x. And then we're going to square the 3 to get 9. So square, together, square. Then we have a binomial and a trinomial. We're going to put x and 3, x squared, 3x, and 9. Then we're going to come back in, I like to use a different color, and do same as the original, opposite, add. Same, opposite, add. And that's it. So if you get the zigzag part down, it's really not that bad. Let's look at it again. X to the third again is x times x times x. 1 breaks into 1, 1, 1, 1. We'll make our zigzag with x and and 1. We'll have square, together, and square. That one's kind of tough because 1 squared is 1 and 1 times x is x. Then we'll set up our binomial, x and 1, and our trinomial. Then we'll come back in and do same, opposite, add. Same, opposite, add. And then that's your answer. This only works for cubes. Let's try it again. We have y, y, and y. We have 4, 4, and 4. Careful here, 64 is a perfect square and a perfect cube, so it's the cube that gives it away. We'll set up our zigzag. We have y and 4, square, together, square. We'll set up our binomial and our trinomial, y and 4, y squared 4y and 16. And then we'll come back in, same, opposite, add. And that's all there is to it. It's just a matter of practicing. If you'd like to pause the video and try the rest on your own and then play it back, I'm going to pick up the pace here a little bit. So 8x to the third is going to be 2x, 2x, and 2x. So 2, 2, 2, x, x, x. 125 is going to be 5, 5, and 5. We'll make our zigzag. 2x and 5. 2x squared, we have to square the 2 and the x. 2x times 5 is 10x. And 5 squared is 25. So be careful there to make sure you're doing everything that needs to get squared. Then we'll have our binomial and our trinomial. 4x squared, 10x, and 25. And then we'll come back in and do the same as the original, opposite, add. So same, opposite, add is the same pattern every time. The numbers can get a little big, but that's why you have your nice little chart. So 125 comes from 5. So 5y, 5y, and 5y. 343 comes from 7. 7, 7, and 7. We'll have our zigzag, 5y and 7. We have to square the 5 and the y. Multiply them together and square the 7. We have our binomial and our trinomial. Hopefully you're getting the hang of this. Whoops. 35y and 49. And then you come back in and do same, opposite, add. Every time, same, opposite, add. That kind of takes the stress out of memorizing both formulas. You just think same, opposite, add once you get your your binomial broken down. Alright, same idea then when you have multiple variables. So this is P, P, and P. This will be 2Q, 2Q, and 2Q. We have our zigzag, P and 2Q. The textbooks always like P's and Q's. I think they're kind of annoying, but whatever letters are fine. So we'll square, bring it together, and square. We'll have our binomial and our trinomial. P squared, 2PQ, 4Q squared. And we'll come in and do same, opposite, add. So no matter how complicated it looks, you can still break it down into the zigzag and then same, opposite, add. Here it looks kind of complicated. We've got these y squared hanging out. I'm going to take them out as a GCF. So we're going to take out y squared. That leaves x cubed plus 125. And then we can factor from there. So we'll have x and 5, x squared, 5x, and 25. So y squared will be out front, and then x and 5, x squared, 5x, and 25. Everything else is the same, same, opposite, add. And last but not least, we've got 54y cubed plus 250. The y cubed kind of gives it away that it should be cubes, but 54 is not on my list, and 250 is on my list. So I'm going to look for a GCF. The GCF is 2. When I take out a 2, it becomes 27y to the third plus 125, and those are both perfect cubes. So then I can set up my zigzag, I'll have 3y and 5. That's 9y squared, 15y and 25. I'm going to have my 2 out front, then my binomial and my trinomial. And then I'll come in and do same, opposite, add. So process is the same even if you have a GCF. If it doesn't look like cubes, look for a GCF. The cubed power will give it away. And it's nice with cubes because they can be adding or subtracting, and the technique is the same.